Hey everybody, again talking to you about these different forms of these quadratics and some application problems that go along with it here. In this problem, we're working on the very last problem actually, on the vertex application problems. I picked this one just because we have the object launched again, so the wording in the actual problem is very similar. But we have a function that appears different, and here we have h of x is equal to -5 times the quantity x minus 4 squared plus 180. This right here, hopefully at this point, kind of familiar to you there, that this is in vertex form. We like vertex form because it gives us the vertex very easily. What comes along with the vertex, of course, it's kind of, expected, I suppose, vertex form, vertex. But our x value is the axis symmetry, and then our y value is whatever we plug in for x. We really like the axis symmetry when it comes to the graphing problems you've had to do, just because that's our mirror. That's the location where things are equal on other sides, but the x value at the axis symmetry really sets the tone when it comes to that mirror. So let's talk about, there's three problems here. We actually just left off with this if you're watching the intercept one before you watch this. The height of the object at the time of launch. So again, I see the phrasing in time of launch, start of a business, starting of a certain scenario. When something is just beginning in these problems, the pattern always holds true, that in this case, time of launch for us would be at 0 seconds. We know that our x value is in seconds within the problem. So 0 seconds, again, I got to do a little bit of math work here. I got to take 0 and plug it into the function. So pause here to write down some of this math here. Inside the parentheses, follow the order of operations in the parentheses here first. 0 minus 4 is -4. Then I have to apply the exponent. So -4 times -4 would be 16. Then I got to do a little bit of multiplication. -5 times 16 is -80, I believe. Hopefully that's right. And then finally, -80 plus 180 would be 100. So at the time of launch, this object would be 100 meters off the ground at the time of launch, which we know is at 0 seconds, 100 meters off the ground. The next two questions over here, small space, use the context clues to understand. There's probably not a lot of work to be done here, and here's why, because both questions have a reference to the word maximum in the problem, and we know that maximum or minimum, depending upon the problem, are words that lead us to the vertex. Now, this is in vertex form, so it shouldn't be terrible to figure this out. The question says here, what is the maximum height? And down here, when will the object get to the maximum height? So this is the time question here. This is the height question. Here's how we figured this out. Inside this parentheses here with the squared attached to it, that right there will let us know the axis of symmetry, the x value for this vertex. The y value would be the height. So we'll apply our zero product property. Take a look inside the parentheses. X minus 4 is equal to 0, which means that our axis of symmetry, the maximum height, would be reached at the time period of 4 seconds within this scenario. Up top here, what is the maximum height the object reaches? That's usually the constant on the back end of the vertex. All right, so here we know that the maximum height would happen at 4 seconds. The maximum height actually in this problem is 180 meters. So again, when it comes to maximum, not a lot of work on the vertex side of things. We really like the vertex to give us that information.